Okay, so for today's lesson, we'll be doing fabric identification methods. Fabric identification methods. Though in our previous lesson, we just learned to identify the fabrics by their names, and that is when the fabric is complete. Okay, like this. That was what we did last in our last lesson. We were able to state the names of some fabrics, identify their names. But today we are going to identify the fabrics and the methods that we are going to use to identify it. It means that though we know that today you said you are wearing paradise satin. So we know that this is paradise satin. But we want to identify the fabric properly. We want to relate it to its correct basics, which is the fiber. Which fibers have been blended, or which particular fiber has been used in making this paradise satin? Is it a cotton blended with linen, or is it rayon and nylon, or is it only a cotton fabric? So the method that we use will help us know the fibers that have been used in constructing the fabric structure. Are we okay? So that is for this particular lesson. Now, don't come. Go. If you are far, it's better. So we aren't going to do practical test on fibers. This is not for this lesson. This lesson will be the theory part. So we will be doing dyeing and all those things practically. Okay. So let's talk about the first fabric identification method, which is the feeling test. How do we know a fabric structure, the basics of a fabric? By feeling. First of all, we use our hands to touch, to feel. We know that cotton mostly is softer and all that, and we can feel certain fabrics easily and even be able to identify them easily if we feel it. Silk is an example. When you feel silk, it is slippery, very slippery, and then we know that, oh, this is silk. It's very slipperier than the satin we have been the different types of satin. That one is even lighter. Okay, and then something like wool, we can also feel wool and know that this is wool. Aside as feeling too, we use our eyes to see. So there are certain fabrics, your eyes can tell you that, oh, this is woolen, this is cotton, this is this, to a large extent. So the finish of the fabric can easily be identified. So you can determine how stiff it is, how smooth it is, the general feeling. You run your hand over it. There are some fabrics like velvet that have projections, shorter projections. You run your hand over it, you know that, oh, this, I'm seeing velvet. Yes, this is velvet. We have woolen. Some wool fabrics have the nap. You will see it as well, but you feel it also. You know that this is a woolen fabric. So one of the easiest or fastest way of identifying a fabric is through the feeling test. Now, let's move to the next test, which is the burning test. That is the second easiest method. So how do you burn the fabric? First of all, how do you burn the fabric? All you need is your fire, maybe a matchstick or matches, like we call it. Then you need your a small, but not plastic, pallet or something like that, not a plastic type. And then what else do we need? I think those are the common things, and the fabrics that you want to burn. When you burn them, you are going to experience certain things, and you have to observe the fabric as well. You whilst it burns, it will smell. The smell will give you an idea of what fibers have been used to construct the fabric, it will also give you, some of the fabrics will give you flames, and the flame it will give you will be in a certain color. Some colors will turn bluish, some will turn a bit reddish, so it depends on the kind of fiber you are burning. Some will give you flames too, some too will not give you flame, they will only melt away. Some will catch fire easily, like it will rush with the fire, some will be slow. Okay, and after it burns, some of the fabrics will give you a residue, like an ash. And even if it gives you an ash, in what forms did it give you that ash? Some ashes will be like just powder, some will come in rounded bead form, a lot of it. So all those things will tell you that, oh, this is this fiber, this is this fiber, and you need to know which fiber gives this before you do the burning test. So once you do the burning test, you can confirm that, oh, this fabric behaved this way, so this is this fiber. So the fiber is identified by noting the odor, the smell, the residue, the remains, or how the fiber approaches flame. Like I mentioned, it can melt or any other thing. Another characteristic is that the fabric can decide to burn slowly or rapidly or melt or not melt. All those things are considered. Okay, we'll be looking at the different types of fibers and then how they behave. Now, these are the items that are needed for the burning test. So we have a 4 centimeter square piece of fabric or 4 inches long fibers from the fabric. Okay. Now look at this in-depth explanation. They said, remember that warp and filling yarns may be different in the same fabric and therefore should be burned separately to determine the entire fiber content of the fabric. Which means if you have a cotton fabric, before you, okay, let me not even say cotton fabric. When you have a type of fabric that you want to identify, let's assume that the fabric is blended. Okay, maybe they decided to blend nylon and cotton. All right, and this particular statement is saying that if we want to do the burning test, we have to burn the warp thread separately from the weft thread. Why? This is a blended fabric. It contains two different fibers, and it is saying that maybe it is only the warp that has the nylon content, and then the weft is the one that has the cotton content. So if we burn it together, it may behave in a different way, and then we may not be able to really identify the exact fibers that are in there. So the advice is that it is better for us to get an accurate result. It is better for us to use pin, remove the yarns one by one from the piece of fabric you want to burn. So you remove the warp. We know where the warp thread is on the selvage, okay, the grain of the fabric. So we will remove some samples, the yarns one by one from the grain or the selvage of the fabric, and then we remove the weft also separately. So we will burn the warp and see how it behaves, record it, burn the weft, see how it behaves, record it. Then we can tell that, oh, this fiber and fabric is made with only one type of fiber, or it is made of two different types of fibers. And it will tell us exactly, because now that we've separated it, we'll be able to tell. So this gives you a better result, an accurate result than burning the whole fabric all at once, especially if it is a blended fabric. I hope we understand this one. Right. Then, so some of the materials, the fabric, a ceramic pot or steel pot or a microwave safe pot or aluminum foil. Something you can, when you burn the fabric, you put it on the fabric because we don't want anywhere catching fire. That's all. So we have a tweezer to safely examine the fibers without burning your finger. You know what a tweezer is? You know what a tweezer is. So yes, just to hold the burning fabric, so we don't put our finger and be holding it. And by the time we realize, the fire has caught up with our fingers. So We are being advised that we do not use big pieces of fabric. If the fabric is the type that catches fire easily, we will catch fire in the room. It will just catch fire, and we also have fan and oxygen here, so fine. We'll just to just catch fire properly for us. So you light a match and put it close to the fabric. That is the process of doing it. You put it close to the fabric inside the pot so that it catches fire. Look at the flame carefully. Please, over here, the pot does not really mean something that has a hollow part. Okay, but you can use something that has a hollow part with the mind that when it is burning, it is covered, so it doesn't, spread to somewhere else. So look at the flame carefully. These are some of the things to consider to be able to identify what fibers it is. Does the fibers shrink away from the flame? Smell the air near the fabric as it is burning. How does it smell like? What is the odor of the flame? When the flame is gone, look at the remnants in the pot. The remnants are the residue, okay, what the ashes that it leaves. What do you see? What does the residue look like? So you note all this down and you press very gently with a fingertip in order to feel the ashes. Like I mentioned, some ashes, they are like beads. They are a bit harder. Some are very smooth powder. So it will tell you. So those are the things that we need to look at when we are doing the burning test. Now, how does different fabrics behave after we have looked at these characteristics? We are burning the fabric, so we have noted down all the points we just discussed. Now, if it were cotton fabric, how would it have behaved? Looking at all the points we have already noted. So, a cotton fiber. A cotton fiber, yes. So this fiber, the cotton fiber catches fire easily and burns vigorously and quickly with a yellow flame and has an afterglow and leaves a soft ash gray or white as a residue. So the ashes are smooth. That's what it's just saying. And soft. So if you record anything like this, it means that fabric is made from cotton, pure cotton. Nothing is mixed. It also gives a smell of burning papers, leaves, or wood, and leaves soft gray colored ash, or sometimes nothing at all. Why does it burn like paper, leaves, or wood? Like why does it smell like that? Like the burning paper. Sorry, I can't hear you. Yes, it's a natural fiber and it is coming from a plant. And paper, the basic root of paper is plants. We have leaves also on plants or trees. Then we have wood also. So it will smell in that this thing, okay? Yes. So that is for cotton fabrics. Now linen fabrics. The linen fabrics also are natural, are made from a natural source. So the natural fibers, when you burn them, the linen fibers, sorry, they catch fire easily. They also catch fire easily because it is from a natural base, just like cotton behaves. It burns with a yellow flame and also has an afterglow and leaves a soft ash gray or white as a residue, just like cotton. It also smells like burning papers, leaves, wood, or leaves a soft gray colored ash. So that is for linen. Okay, linen also behaves just as cotton fabric, but linen. linen with the feel, you will know that it is more stiffer than cotton. I hope we understand. Yes. So if you have these, you do this burning test and you are now confused. The truth is, you actually had the fabric before burning it, so you definitely know the difference between the cotton, even with feel, with the feeling test before you do the burning test. Anyway, now let's move to the next type of fiber. So we have the wool fabrics. The wool fabrics. Now, how do the wool fibers behave if they are bent? So when bent, they do not catch fire easily and they burn with a yellow flame. Mind you, it's also natural, but it's not coming from plant based. Yeah, it is from an animal. So with a yellow flame, and go on to have an afterglow and leave a soft ash gray or white as a residue, just because it is natural. So it is also giving us that soft ash gray, ash or residue. This is telling us that all the natural fibers usually give this, they give soft residue or ashes. Do you understand? Because it is natural, so it is giving us a soft residue. And it also gives a smell of burned human hair. Yes, it is the hair of an animal, so it has to burn like hair. So that is it. So I asked a question, an interesting question. What if I do not know how hair smells? We'll go and cut a wig and then burn it, Abby, and smell it, and then come and burn this one. Then we will be able to tell that, oh, we've recorded that this is smelling like hair, like that. So this must be wool. All right. So let's look at the silk fabrics too. Silk is also animal based. Okay. So let's look at how it also behaves. However, silk fibers, they shrink away from the flame. It's like it is melting, kind of. Okay. So it does not continue to burn after the flame is removed. When you blow air and the flame leaves, it does not burn again. Do you understand? It will not burn again. Assuming there's a strong wind blowing and then the fire goes off, it will not burn again. It won't melt. It won't melt. It won't even melt. That is the end of it. So silk burns with a smell of burning feathers. Those of you who don't know how burning feathers smell, do you know what it means? It means that you have never or experienced, let me just say, you have never experienced where they have killed a live fowl or bird, any type of bird before, and prepared it live in front of you and you have eaten before. Because if you have, you know how feathers smell. Because if you want to dispose of the feathers of a bird, is either you are burying it, you are burning it, or you are putting it in that, depending. But in any case, if you do that frequently in your house, you know how it smells, because one day you will be burning those things. I hope you get it. So it burns like feathers, the smell of feathers and leaves, an irregular shaped black bead as a residue which will easily powder to ash. It also gives the smell of burned hair. Look at the feathers here. Look at the hair. And the thing is coming from an animal, a cocoon for that matter. Okay. All right. Any questions on this silk? So we continue. It leaves an irregular shaped black haired bead. When after it is burnt, it leaves small ashes, but they are round as in irregular, not perfectly rounded. Okay, an irregular shape, it will be in different forms of shapes, but then when you pick one, it can easily be crushed. When you put your hand on it, to just crush into a powder or a soft powder form, since it is a natural fiber. All right. Then we have acetate fabrics. Acetate fabrics. This is where when you get to this kind of fiber, then you are telling us that, oh, okay, so this is acetate. This is how acetate looks like. This is what it. We have so many fabrics, and we do not even know that they are acetate fabrics because we have so many tabletop names for the fabrics, such that we don't name the fabrics after the fibers that have been used in producing them. Or yeah, so acetate fibers burn and melt even after the flame is removed, unlike silk. So if we are burning an acetate fiber right now, if any wind blows and the fire goes out, it means that that fabric is will continue melting because there is heat in it. So it will continue, it will melt until it exhausts the this thing of the temperature that it has. So it leaves a hard bead. This one, it leaves the bead is hard. When you touch the residue, you realize that it is hard. Okay, so that is how you tell the difference between an acetate fabric and then a silk fabric. The silk fabric, even if it leaves the flame and the ash is in irregular shapes. Once you put your hand on it, it will crash. It's very soft. But this one is harder. And aside that, when the fire is removed or the flame is removed, it keeps melting. Okay. Now let's go to viscose fabrics. We've been hearing viscose rayon, viscose rayon. Whatever, what is it? Let's look at viscose fabric itself. So viscose fibers, they catch fire quite easily like cotton and make a big flame soon enough. Those fabrics that looks like you've poured petrol on it. Yeah. And the smell of the fabric burning is that of burnt leaves. This is also a natural fiber, actually. So it's burnt leaves. When you touch the remnants, they feel powdery. Okay. Then we have the nylon fabrics. One common, I don't know if I should say it's a mistake we make is differentiating nylon from silk. When you start learning fabrics, you usually get confused about which one is nylon and which one is silk, because nylon sometimes like the look behaves as if it's almost silk, but it is not. Silk is very slippery, very, very slippery. I mean to touch. But so nylon fabric is synthetic, it's a synthetic fiber. It's not natural at all. It melts without burning. It won't even burn. It will just be melting like that. And sometimes burns slowly. A hard bead forms and smells like burning celery or a slight sweetish smell. This celery here is the vegetable we've been using to cook. Go and type celery and then you find a picture of it. It's a vegetable we use to cook. Just that we don't like using it a lot, but we those who like veggies, any veggie we are buying. Yes. So the smell, that one I won't blame anybody. If you don't use it, you may not know how it really burns. Yes, or a slight sweetish smell. But if something is burning and the smell is sweetish, like toffee, like you will know naturally with our senses. You will know. Even if you can't describe the thing, but you know the smell is sweet, it's nice. Yeah. Then we have the polyester fabrics. The polyester fabrics, they burn very quickly. They burn and melt when ignited and continue to burn even after the flame is removed from the fabric. They produce, if we talk about removing flame, what it really means is I have lighted a matches or a lighter and the fire is on and I have lighted the fabric. Okay, whilst the fabric has started burning, once the fabric starts burning, I remove the fire or the lighter from the fabric. That is what they really mean here by removing the flame. Do you get it? Because when we do the burning test, and even if we use a matchstick, we are not going to use the matches. We are not going to leave the matches on the fabric until the fabric finishes burning. Once the fabric is able to catch some fire, we are going to remove the fire we use. That is what we mean here by removing fire. Please, I hope you understand. So you don't mistake my wind thing. So they produce smoke as they burn, and this may be toxic. Yes, it will be toxic because it's not natural. Yes. So the smell of fabric burning is that of chemical vinegar or burnt plastic. We all know how plastic smells or vinegar smells. We know they leave a plastic-like bead as residue, and there will be small hard lumps in the ashes. Okay, there will be hard lumps in the ashes. Now, this is a table that gives us how each fiber behaves during a burning test. This is just for burning. So you see our first column, we have types of fabric. Then in our first row, we have cotton, hemp, remy. Then we have linen. So let's use the first one, cotton. So these three fibers behave the same way. This tells you that this hemp and remy are natural fibers. So they all do not shrink away from flame, ignites easily on contact with flame. Then burning behavior. They burn rapidly with a yellow flame and light gray smoke. Odor flame, burning paper. Burns like paper, smells like burning paper. After the flame is over, continues to burn. There is an afterglow. Type of ash. Type of ash. Soft gray, powdery, smooth ash. You see, so it's the same thing for all the fibers we've listed here. So this is like a summary and a table form for you to study. This table is good for those who don't like reading one sentences. So you can as well study this table. Okay, you may find yourself somewhere to explain the same thing to somebody. Now, before you attempt any of this, especially the burning this thing process to identify fabric, you need to protect yourself from the flame. So these are some of the things you need to do. You have to wear a non-inflammable clothing when using the test. Because it is fire, you are supposed to wear something that is, how have we been calling it? You have a name for it. Something that is non-inflammable. We have a roadside name we've been calling it. I forgot it. But your clothes, it is fireproof. Yes, fireproof. Something like that. So it means you can have your normal clothes on. So even if it is an overcoat, which is fireproof, you have to wear it, to prevent yourself in case the fire spreads mistakenly. It will not catch whatever clothes you wear. However, maybe that day you are wearing silk. So the overcoat will help you. The overcoat will help you, because it is not inflammable. Then, if the person is the kid, if a kid is trying to experiment, maybe a kid has made this video and wants to experiment. So the kid should make sure that an adult knows that, oh, mommy, daddy, sister, I want to do this, or I want to bend this, so the adult can come and oversee the operation before the child gets bent. So you use these tests on flammable materials with utmost caution. Okay, that one we all know that we have to be cautious with fire. So you have to also keep a damp woolen cloth nearby to put out fire, which means, let's say for example, we get something like a towel. We have dipped it into water. It has absorbed water already a lot. So when we burn our cotton fabrics, After we have recorded everything, we need to put out the fire, right? But the fabric is still burning, so we'll just put the damp cloth over it, and then the fire will just quench like that. So we keep hair out of flame and do not allow the burning material to touch your skin. That one, yeah, we all know. But the hair, we ladies will have wigs on 10 inches, 15. In fact, the best thing is to hold the hair. The best thing is even to put it inside the, how do you call it? A cape. And be free. Otherwise, with this your long braids like you are having, you forget yourself. You turn your back and it will catch fire. You will not even know. By the time you know that something is happening, it has burnt your skin. That's when you will now feel it. But what is happening to your hair is a lot. Okay. Any questions? Any questions? Right. So we'll look at the microscopical test. This one is the microscope. Like I said, you only is easy. You only view your yarns and fibers with a microscope. But with a microscope test, it's normally advised that when you remove the yarns, okay, you try and spread. You know when you have a sewing thread. You know the sewing thread contains so many other, let me just say, threads before it became one. That it was twisted, the fibers were twisted together. So if we cut a piece of sewing thread and we split it, you will see that the fibers are many. So that is how we are supposed to split the fiber, the yarn, okay? The yarn of the fabric before we view it with microscope. All right. Now, so to get quick, accurate results, it's easy to perform for the identification of this using this method. So even the yarns containing fiber ends can also be easily tested by the methods. There's something I want you to look at. Okay. So the test donates a cross-sectional and longitudinal view of fibers. So this is what I have explained already. To do this, okay, so the latter part of the explanation for microscopic test is what I just explained about pulling out the yarn and spreading it. But one thing you have to do to soften the fiber and to make it easy for you to see the structure, after opening up the fibers, you need to drop distilled water on the fiber before you examine it under the microscope. Now, you can buy distilled water from the counter. Okay, even some pharmacies sell distilled water. You can also make distilled water yourself at home. How do you make distilled water? How do you make distilled water at home? Vapor? Okay, something like that. So when um, you put water on fire in a pot, the cover, the lid of the pot, if it is the hollow type, you can turn it upside down. So when the water is boiling, the vapor converts into another, or the steam converts into another form of water on top of the lid. The ones that gather there is distilled. So, like he's saying, it's just trapping of the vapor. So the vapor turns into the other part of it, which is the distilled water. And this, you need a pinch of distilled water so you can do something yourself and get a distilled water for that purpose. All right. So we have cotton fabric. We've done cotton fabric already, but this is under microscopic test. We did cotton fabrics under burning test. So under the microscope, how does the cotton fiber behave? So the cross-sectional view is bean shaped like a beans, eh? the way beans, you don't know beans. So if you view cotton under microscope, it will look like a beans, the shape of a beans, not the beans itself. I'm talking about the shape. The longitudinal view is spirally twisted. When something is twisted, just like the sewing thread that we have, but it is spiral, it is round, it looks round and it's twisted. It's just like you have placed a sewing thread on the table and you have coiled it like a coil. Okay, right. Tube with a rough surface. It will look rough. The finished cotton fiber will be swollen, straight, smooth, and round with a shiny surface. All these things you are seeing it with your eyes through the microscope. So once you see these characteristics, it means the fiber you are testing or identifying under the microscope is cotton. If the fabric has a nap, what is a nap? Just like woolen towel, for example, you see it has those nap. I don't know how, those naps on it that you can cut through those projections, but that one is looped. Exactly. Do you understand me? Yes, those are the nap. If the fabric has a nap, when you run a moistened finger on cotton fibers, the fiber will lie down. In color, cotton fibers will be whiter. Okay, they'll be whiter in color, soft and dull. So when you are viewing even the color, cotton fiber will look more whiter than any fabric that you view under the microscope. Do we get it? Do we get it? Cotton itself naturally is white. Yes. You've seen a cotton plant before. Gani gani. All right. So that is for the cotton fabrics. So let's look at the linen fabrics under microscope. So they have knots at intervals like a piece of bamboo. You used bamboo in one of your lessons, and we know how bamboo is like. It has joints. Those joints is what is called knots, and that is exactly what you see when you view linen under microscope. Okay, with many joints in color, linen fiber will be stiffer and creamer in color. Okay, it will look stiff, not relaxed. Then what about wool fabrics under microscope? It will be springy. It's not spring rolls. It will be like a spring. It will look like it's bouncy. Okay, a bouncy and resilient and somewhat lustrous, as if it has a little bit of sheen there. Huh? So if the fabric has a nap, when you run a moistened finger on the fibers will spring up. That is, if it is a woolen fabric, they will stand up. They won't lie down flat like that of a cotton. Then we have silk fabrics. Silk fabrics under microscope will be straight, very fine and smooth. Under the microscope, the silk fibers appear as thin, long, smooth, and lustrous cylinder. It means that it will look like, you see this thing, like round like this, like a cylinder. And they will have a little bit of sheen, like as if it looks smooth, like wants to shine, something like that. Now, cloths made from silk include brocade, brocatelle, chiffon, crepe, etc. All right. So these are silk fabrics as well. Then we have acetate. So I don't want to waste time on each of them, reading them. So on your own, you can go through the acetates as well to know how acetate also looks like under microscope. Same as rayon and then viscose fibers under microscope. Okay, there's a viscose fabrics under microscope. So this is a detailed test for those who are studying Textiles, I mean fabric itself as a course, as a program, not course, as a program. Okay. Then we have also for the nylon fabric too and polyester fabric, the same fabrics that we studied for the burning test. Yeah, we have. I have a link here which is a guide to the information I have just given you. Over there, you may see other pictures and whatnot. So, since you'll be having a copy of the presentation, you can check this out later since it's not a video for us now. So, let's continue. I have my last two slides. So, we have the chemical solubility test, the chemical test. So, these are tests that help to determine the fiber content of the fabric. Here, solvents are used to identify one fiber from the other. The solvents are solutions, they are chemical. And when you pour these chemical or solvents onto, solvent means the thing is liquid. When you pour it on the fabric, it will give you, it will behave in a certain way. The way it behaves will tell you what particular fiber it is made from. So reactions of fibers to common acid and alkaline solutions are used in this test. Acetate fiber will dissolve in acetone nail polish remover. This is just an example. Over here, I haven't cited how cotton will behave with what chemical because once I state cotton, I have to write how cotton behaves when acid is poured on it and how cotton behaves when an alkaline solution is poured on it. Do you understand me? To behave in different ways if I should pour these two separate solutions on it. Do we get it? Yes, and the truth is, okay. So we have the tensile strength test. What is tensile strength? You good. Tensile strength is how durable the fabric is, especially how long is the fabric going to keep before it tears. You know, you don't need to put blade or scissors or any cutting tool on it to tear it, but on its own, how long can it hold before it gets torn? Now, these are tests done during fabric development and manufacturing. When the textile designer is manufacturing the fabric from the basics, he or she does a lot of tests with the fibers that he wants to use to test their tensile strength before using it. For example, the person knows that this fabric I am making, I want to make the fabric and use it to bag cocoa. Let's take it for example. Now you know that it means that this bag is going to go into the farm through which kind of transport? Even after bagging the cocoa, probably you are going to drag it to somewhere. Maybe you are not, so it is going to go through, I'll say in quotes, the fabric is going to go through a level of stress on its own. So if you are producing a fabric for such a purpose, you have to test the tensile strength before you even manufacture the material. So you are sure that you are using the right type of fiber for the right kind of fabric you are making because it's going to be for a particular job. So that is why it is mentioned here that it is done at the fabric development and manufacturing stage. So strip tensile strength, grab tensile strength. There are all different types of tensile strength tests. So tensile, okay, test and wide width tensile test are the different tests used. In the strip tensile strength test, the fabric is pulled from both ends and the tensile load is applied to test its tensile strength. Once they apply a tensile load, like pressure, if they will see the amount of pressure it can take, whether it's tearing easily or it gets to a point, it stretches to a point before it tears, or it is able to keep its original state even though they have added some pressure to the yarn. Okay, so they do all this, and the grab tensile test and wide width tensile test are used for industrial fabrics. Okay, they are you they those tests are used for industrial fabrics. So this is the end of our lesson on fabric identification methods for today. Any questions? Any questions? So we will meet in our next lesson. Okay, so all the practical and whatever it is will come. All right. Okay, thank you.